right, I'm going to go through the 2010 FRQ number 6. So it says, respond to the following statements and questions that relate to the species and the reaction presented above. So first of all, it asks for the complete electron configuration for zinc 2+. So the one thing you need to be careful about, keep in mind that the original configuration had 3p6, 4s2, 3d10, but remember that you need to remove the 4s2, okay? Because that's the highest, 4s is the highest energy level, and therefore you need to remove it from there. So you got 1 point for that. For B, it says, which species has the greatest ionization energy? Okay, so we know that zinc has Zn2+, the ion has like the greatest ionization energy. And remember, the reason why is Zn2+ has fewer electrons, and therefore it's going to be more attracted to the nucleus because its electrons, you can say its electrons are closer to the nucleus, or its electrons experience a larger effective nuclear charge. Okay. The other option is, and I didn't think to say this, but it takes more energy to remove an electron from a positive ion than from a neutral ion, than a neutral atom. So that would work as well. I normally just think about the fact that you've removed electrons, therefore it has a greater effective nuclear charge because you have fewer electrons, and the electrons are closer to the nucleus, which they didn't put as an option, but I always think about it that way. But larger effective nuclear charge, or the fact that you're just removing it from a positive ion. Which species is oxidized? Okay, we know that aluminum is going to be oxidized because it is losing electrons, but you don't need to explain it, just identify it. So you would say Al. For D, it says the diagram includes a salt bridge that is filled with a saturated solution of potassium nitrate. Describe what happens in the salt bridge as the cell operates. So keep in mind, since aluminum is being oxidized, it is becoming Al3+. So the mass of aluminum is decreasing because it's becoming aluminum 3+. So in order to avoid that positive charge from building up, NO3- is going to move into the anode. Meanwhile, K+ is going to move into the cathode because Zn2+ is becoming solid zinc. So the mass of the zinc is increasing because it's being reduced. So K+ has to move into the cathode. NO3- moves into the aluminum half cell, while K+ moves into the zinc half cell. So you get 1 point for the correct description. So you don't need to go into all of that explanation that I did, but I just wanted to make sure we were clear on that. Determine the cell potential. So if we go back, so you will actually need, so for this problem, because this is a 2010 problem, they actually gave you your cell potentials just on a huge chart. So you needed to go and look for aluminum cell potential and then also zinc's cell potential. Aluminum's being oxidized, so you needed to take the negative of its value. Okay, and so the answer you should have gotten is 0.90 volts. Volts. Now be careful, a lot of people forget to put volts for their units, so just be careful with that. Indicate whether the value of the standard free energy is positive, negative, or 0. Well, your delta G, since your cell potential is positive, delta G is going to be negative, okay, and therefore it's going to be spontaneous. So you got 1 point for indicating that your delta G was negative and 1 point for your correct justification. So either noting the fact that your cell potential is positive and therefore delta G is negative, or noting that the reaction itself is spontaneous and therefore delta G would be negative. So that's 2 points. All right, for the next problem, it says if the concentration of aluminum nitrate in the aluminum solid aluminum solution half cell is lowered from 1 to 0.01, does the cell voltage increase, decrease, or remain the same? Okay, so if you look back, okay, remember this is my reaction. Aluminum becomes aluminum 3+. So by lowering the concentration of aluminum 3+, I am decreasing the concentration of a product, which means my reaction would shift to the right. And since it is shifting to the right, my cell voltage would increase. Now, the way to explain this, you can't just say it's shifting to the right, therefore the cell voltage would increase. You would say since your Q is going to be less than K, it will proceed to the right, and therefore your cell voltage would increase. Now, this includes the Nernst equation, which is not something that's now covered in the new AP, so you're not expected to explain it that way. Okay, so you got 1 point for indicating that your cell potential increased, and then 1 point for the correct justification.